All right, are we live? Hello, 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 hello. Guten Abend, good day. So here we are. We have another problem. So praise God for His mercy and His grace and for yet another day. Thank God. Really grateful. And I usually like to wait a few seconds before I get going, just to get started. So I'm going to look at the non-overlapping intervals question from Leetcode from the other day. I want to revisit that. I kind of had something of a solution that I was talking about, sort of talked out a solution previously, and I just wanted to finish where we started on that. I don't know what I'm doing today, quite frankly. My mind's all over the place. I'm getting like really sick, also. Sort of different problems occurring, I guess, different reasons for that. But I'll probably just solve one problem today and then think about what I want to do afterwards. But if I remember the solution for this correctly, which I think I do, what we're going to do is there's something of an algorithm to basically, we're going to dump all of these intervals into a hash map and process the intervals, all of the intervals that are either equal to each other or overlap or encompass each other rather. We're going to reduce them to non-overlapping, non-encompassing, or the intervals that start at the same left side. All of those intervals, we're going to kind of simplify our input by dumping into a hash map so that each interval that starts with a particular left side, that's basically unique. Basically, it's unique. We're going to start with that. And then the processing we're going to do is really simple, actually. We're going to sort the list ascending on the left side, right? We'll call it XY, so left side is X, Y is right on the interval. Sort the X values. And then what we're going to do is we're going to walk through the sorted list, counting overlapping intervals that need to be removed. And the algorithm is going to be, so you have a point A and point B, or integer A, or index A, index B. The interval at A and interval at B, we're going to compare them. We're going to start off by looking at the first two. So A is 0, B is 1. And we're going to look at the Y values for the intervals. The one that has the larger Y value is the one that we're going to skip over. So if there's no overlap, right? First you check that. If there's no overlap, that means that the X value of the B interval is larger than or equal to the Y value of the A interval. So if there's no overlap, then we're going to not increment the count, and we're going to shift A to where B was and B to B plus 1. Right, that index, shift the index over 1, and continue our loop. If they are overlapping, in other words, that condition I just gave is not true, right? The else otherwise. If interval A's, we're gonna skip over the interval that has the larger Y value, the one that's sort of further to the right. That's the one that we're gonna dump. And so if that one is A, then we're going to swap A with B, move A to where B is and move B to B plus 1. And increment the count. If it's B is the one that's larger, then we're not going to move A. We're just going to move B to B plus 1 and also increment the count. That's like the whole algorithm. And then after that, we should have a count. That's the minimum possible. I think that's correct. I could be wrong about that, but we're gonna try something like this to see if we can do this. So intervals. Yeah, I think const is fine. Can we do const? We may or may not be able to do const. So we have an unordered map we're going to use. We're just going to call it M. int to int. I don't really know what to call this. We'll go with count. And we're going to say just x is p of 0, y is p of 1. Or obviously we're not doing any kind of validation check on the inputs here. And we're going to say m.count of x, so it's if it's there, and then if it's not there, then m of x equals y. If m of count of x, then you're going to say if m of x is greater than y, then we're going to increment the count, and we're going to m of x equals y. So if y is a smaller value than m of x, that means actually even equal to also. Yeah, so this should handle the logic where we basically eliminate the all of the intervals that share the x coordinate. We're going to narrow it down to the smallest y coordinate and remove all of the either duplicates or ones that have larger, and we're going to count those as overlapping intervals that have been sort of removed from consideration. So we kind of make these as small as possible, these intervals. Then we're going to perform the next logical part, which is we're going to use a sorting algorithm. We're going to dump, so say remove trivially overlapping slash overlapping intervals. I'll just call them trivially or naively or obviously. Dump remaining intervals into a vector and sort on the first coordinate. Right, first coordinate, second coordinate, however you want to express it. Excuse me. Hopefully we can use const auto for these. I don't actually know what this will do. This is going to be actually just m in the map, and we're going to have a vector of standard pair of ints, and I'll call it v. It doesn't really need to have a name, I think. Yeah, I think that's okay. Hope it's okay. And v.begin, v.end, and then we'll just have, well, this is fine. Lambda expression should be fine. I kind of wonder if we even need a lambda expression for this, but it should be okay. We're going to say, yeah, let's do it this way. Yeah, actually, that's fine. Whoops. This lambda expression, we're going to do const standard pair of ints a reference a, same thing. Yeah, that's fine. Okay. So you have A, B, and the idea is kind of simple. I don't know if this is a little confusing. This might be better if we do it this way. Okay. Return A dot first is less than B dot first. I think it's that simple. Yeah. And these are pairs, right? So sorting the pairs on the first value in ascending order. I think that's fine. I mean, it's a little bit, what's the word? Like awkward to code that, but it's okay. And now, perform greedy algorithm. On the remaining intervals in order to remove the least possible. Resolve, yeah. Number of overlaps. And so we'll say A equals 0, B equals 1. B is less than V dot size. You always increment B every time, no matter what happens. So really it's just a decision on what happens to A. So we say if overlapping, we want to have auto P1 is V of A and auto reference P2 equals V of B. So overlapping is if P1 second is greater than or equal to P2 first. All right, that's pretty much what it comes down to. It's got to be greater than. Non-overlapping, move A to B, increment B. Note, we're not just incrementing A, we're moving A to where B is, because there could be a whole bunch of things that we skipped over in the middle. So A doesn't just like move forward one at a time. A moves to where B was, and B just increments the next. Now we say overlapping, we're going to increment the count because we're going to resolve. And we're going to say which one do we modify. We say if which one is longer, basically. So P1 second is greater than P2 second. Then we're going to say it doesn't matter if they're equal which one we remove. So if P1 second is larger, we want to remove P1. So A equals B. Otherwise A doesn't change, actually. You just increment B. Yeah. So, move A to B, effectively skipping pair interval A. And I think this will work at the end of all that. Oops. Let's see what happens if we do this. Wrong. Nice. Really? Okay. That's alright. I guess not. What? This step should have incremented the count. Actually, the count always increases. I'm sorry. That was my mistake. That's probably why it's wrong. Yeah. Yeah, the count is always every time. The count's always going to increase if we whether or not we update or don't update. One of these is going to get tossed, and we're going to keep the smaller one. Should we just go for it? I'm tempted. I feel like I need a little more testing. How are we doing on time? 15 minutes. Given that I already knew the answer to this, it seems kind of bad that it took more than 15 minutes, but it's okay. Sometimes it takes a while to code things, I suppose. Just 1, 3, 2, 5, 3, 6, 1, 7, 8, 9, 100 and 500, 101, 102, 100 and 100 to 200. Just kind of throwing in random things here. I don't know. Does this work? It does. Okay. How about, what are some edge cases? Oh, the interval length is always at least 2. That's interesting. I don't know. Maybe throw some negative things in there. -1 to -2. -1,000 to 1,000. -5 to -6. I don't really know. I don't know what to. Oh, that's a mistake. When they're negative, the one on the left has to be larger. Has to be more negative. Excuse me. I don't really know what to do here. Start adding things, I guess. 10, 11, 20, and 21 to -20,000. 20,000. I really don't even know what could break this. I don't know. 52,000. Just make these tests. Just add more and more things to the test cases, I guess. I don't know. I think I just go for it. I can't think of anything that might break this. Yeah, I don't know. There's got to be something. I don't know. There's probably something I'm missing. I'm probably gonna kick myself after I do this. Nope, we're right. Okay, got it. Done. Sweet. All right. There's probably ways to improve this, but we'll just keep it as is. I kind of want to modify this logic a little bit. So it says, if not this, then do this. But if this, then do this and check this. Basically, I want to say there's only one case where we don't do this. So I want to say something like we could set A to B, and then if we're not in this case, then we set A back to A, something like that. I think this is fine. Whatever, not a big deal. All right, perfect. That's simple enough. It's simple enough. That's okay. We don't need to go crazy trying to get the logic just right. All right, so thank you for watching. I will talk to you soon. Have a good rest of your day. Hopefully that was enjoyable and interesting. And take care.